Chemistry students, here are some corrections for the homework assignment that was page 186, numbers 25 and 26. Question 25, letter A, asks you to calculate the number of molecules in 60.0 grams of NO2. So I've summarized here what the problem is asking you to do. So again, if you find that you're struggling with these problems, my suggestion is you look at your chemistry toolkit that has those 5 tools on there. And you're looking to see, do you have a tool that has grams in it and molecules, like one single tool? And you don't. Okay? There isn't one. You have a tool that has grams and moles in it, and you have a tool that has molecules and moles in it. So what that's going to mean for this problem is you're going to have to use multiple conversion factors to solve this problem. We're still going to approach it the same way. So we're going to start with our given, which is the 60 grams of nitrogen dioxide. Now, because grams is in the numerator, it has to go in the denominator. So I'm going to put grams of nitrogen dioxide in the denominator. Now, again, when I look at my toolkit, remember that the name of this tool on your toolkit is molar mass, and the other unit for molar mass is moles. So this is moles of NO2. Okay, so easy number for molar mass is 1, and remember the number that goes in front of grams comes from our periodic table. You're going to add up 1 nitrogen's atomic mass plus 2 oxygens, which should be about 46.0005. Again, here you want to make sure, because this here has 3 significant figures, you want to make sure that this number here has at least 3 significant figures. You can use more than that, like I have, but you should use at least 3, okay? So we've used molar mass. We start to look at our units. Grams of nitrogen dioxide is crossing out, but I'm left with moles. I don't want moles, I want molecules. So that means that moles is going to have to go on the bottom. And I want to see, do you have a tool on your toolkit that has moles and molecules? You do. It's one of the count ones. But that one you have to be careful about, because to use that tool, it has to be a molecular compound. Well, lucky for you, nitrogen dioxide is a molecular compound, so I can use that tool to convert to molecules of NO2. Again, I look at my tool on my toolkit. The number in front of moles is easy, it's 1, and in front of molecules, it's Avogadro's number. Again, looking at my units here, moles and moles are crossing out, so I'm going to be left with my answer in the units of molecules NO2, which is what I want. When you do this on your calculator, again, because I want 3 significant figures at the end, you should get an answer of 7.85 times 10 to the 23rd molecules of NO2. Again, for those of you who struggle with using a calculator, okay, so because 46 is in the denominator, remember that means I'm going to have to divide by it. And because Avogadro's number is in the numerator, remember that means I'm going to have to multiply by it. The order of multiplication and division doesn't matter. So somehow in your calculator, you can put it in as 60 times 6.022. Remember, we're using that E button, 3, divided by 46.005. Okay? Putting that in your calculator, you should get the 7.85, okay, times 10 to the 23rd molecules of nitrogen dioxide. Letter B. Letter B asks us to calculate the volume in liters of 3.24 times 10 to the 22nd molecules of chlorine STP. So again, first thing I'm going to do is I'm going to look at my units, and I have molecules and I have liters. And I'm looking for, do I have one tool on my toolkit that has both molecules and liters in it, the same tool? I don't. So again, that's telling me I'm going to have to use multiple conversion factors like we did on the last problem. So again, I'm still going to start the same way. I'm going to start with my given, which is the 3.24 times 10 to the 22nd molecules of chlorine. Because molecules are in the numerator, that means that molecules of chlorine have to be in the denominator. And again, I look at my toolkit. My toolkit, the one that has molecules in it, also has moles. Okay, and to use that tool, I have to be a molecular compound, which this is. So, again, the easy number always is the number that's in front of moles, because that's 1, and in front of molecules, this is going to be Avogadro's number. Right now, units-wise, I'm in moles. However, I want liters. So do I have a tool that has moles and liters in it? Indeed, I do. Moles are in the numerator, so moles will have to go on the bottom, the denominator. Liters of chlorine are going to go on the top. Again, this tool has a special name. This is the molar volume tool. In front of moles is 1, and on your toolkit, number in front of liters is 22.4. So then again, I'm going to put that in my calculator, and you should get 1.21 liters of chlorine gas. Remember, to use the molar volume tool, it has to be STP, which is why the problem said it was STP. Again, for people who are struggling with calculators, again, to put this in my calculator, 3.24 E22. Again, order doesn't matter, so I can go ahead and say divide that by the 6.022 e to the 23. I know I'm dividing because that number's in the denominator, and then multiply by 22.4. Again, I know I'm multiplying because 22.4 is in the numerator. Okay, and that should give you, again, it's going to give you a big long decimal number. I know that I should use 3 significant figures because this number here has 3 significant figures. And when we multiply and divide, which is what we'll be doing when we're working through Chapter 7 and Chapter 9, okay? When we multiply and divide, we're always limited to the number of significant figures of the number that has the fewest. So this has 3 sig figs. Because I use 6.022, this has 4 sig figs. This number has 3 sig figs. So my answer can have 3 sig figs. So taking a look at our next question. Okay. 25 letter C says calculate the mass in grams of 18.0 liters of CH4 or methane at STP. Again, I start to look at my tools here, and I know I have a unit of liter and I have a unit of grams, and again, I don't have one single tool on my toolkit that has both of those units in it, which means I'm going to have to use multiple tools to solve this problem. So, again, I'm going to start with my given, which is the 18.0 liters of CH4, and again, they told us it was STP. Liters go on the bottom. The tool that I have that has liters in it is molar volume, which has moles as the other unit. So again, this is that tool of molar volume. Okay. When I look at that tool on my toolkit, it's 1 in front of moles. It's 22.4 liters in front of liters. Again, looking at my units, liters is crossed out, but I'm left with moles. I don't want moles. I want grams. So I know that moles are going to have to go in the denominator to cross out. Again, do I have a tool that has moles and grams in it? Yes. Again, that tool has a special name. This is the tool molar mass. So I'm using molar mass this time. Again, I can see that my moles are going to cross out, and I'm going to be left with a unit in grams. Again, easy number in all of these tools, right, is that the number in front of moles every time is 1. Okay. In front of grams, to get this number, remember, I'm going to add up 1 carbon and 4 hydrogens, which should be about 16.042426 grams. Again, if I take a look at significant figures, this number here has 3 sig figs. This has 3 sig figs. And this one, the way I've written it, has 1, 2, 3, 4, 5, 6 sig figs. So my answer is limited by the 18.0, which is 3 significant figures. And so you should get an answer of 12.9 grams of methane. Now, again, for those people who are struggling a bit with calculators and such, again, order that I multiply or divide doesn't matter. So I can take my 18, divide it by my 22.4. Again, I know I'm dividing because 22.4 is in the denominator. And then multiply by my 16.0426. I know I'm multiplying because 16.0426 is in the numerator. And when you do that, you should get the correct answer. So that summarizes question 25. Question 26. Would 3 balloons, each containing the same number of molecules of a different gas at STP, have the same mass or the same volume? Explain. So kind of one of the important things here is that we're talking about the gases at STP, and we're thinking about three balloons. Okay. And we know they have the same number of molecules, because it told us that in the problem. And so the question kind of here is, do they have the same mass? Okay, or do they have the same volume, or do they have both? Okay, so again, this one I kind of like, I think it's easiest to think about like a picture. So I have 3 balloons. Okay, and they contain a gas, 3 different gases. And let's decide what gases they have. Let's make this a flammable balloon and make this hydrogen gas. Let's make this oxygen gas. And how about if we make this one helium gas? Right? Okay. So these are our 3 balloons, and we've just picked, because the problem doesn't say what gases they have. They just tell us that it's a different gas. So to kind of make that illustration, we're just going to say, hey, I have a hydrogen balloon, I have an oxygen balloon, I have a helium balloon. Okay? Now, the same number of molecules. Now, that's kind of key here, because there's a special number of molecules I want to decide to use here. I want to use 6.022 times 10 to the 23rd. Why? Why do I want to say all of these contain that many molecules? Well, I write these in here for the balloons. You think about, what's the answer to that? Why am I purposely putting 6.022 times 10 to the 23rd molecules in each? Why didn't I just put 1 or 2? Why did I choose this special number? Did you figure it out? Why did I choose that special number? Because that special number is, oops, sorry about that. That special number is 1 mole, right? I've purposely put 1 mole of molecules in each of these balloons, because that's how many 6.022 is. Now, why would I do that? Because they told me it was STP. Well, what do I know about the volume of a gas at STP? I know molar volume. And molar volume says that at STP, it's 22.4 liters of any gas to 1 mole of that gas. So, What's the volume of this hydrogen balloon? Well, it has 1 mole of molecules. Its volume is 22.4 liters. What's the volume of this oxygen balloon? It also has 1 mole of molecules, which means its volume is 22.4 liters. All right, what about this helium balloon? Again, how many molecules does it have? It has 1 mole of molecules, so its volume is 22.4 liters. So, again, we are seeing right now that they definitely have the same volume. The question is, what about the mass? So let's look at the mass, right? I can calculate the molar masses of these substances, right? The molar mass of hydrogen using my periodic table, that's 2 hydrogens, right? So the molar mass of hydrogen gas is 2.0158 grams per mole. The molar mass of oxygen gas is 31.998 grams per mole. Again, that comes from 2 oxygens added together. And the molar mass of helium gas, or helium, is 4.0026 grams per mole. Now, why is that important? Because again, how many particles did I put in each balloon? I purposely put 1 mole. Well, if I put 1 mole of hydrogen particles, what's the mass going to be? 2.0158 grams of that balloon. In this oxygen balloon, again, I have 1 mole of molecules, which means the mass of this balloon is going to be 31.998 grams. And this helium balloon that also has 1 mole of helium, actually technically atoms, okay, its mass is going to be 4.0026 grams. So going back to that question about, is the mass the same? No. Okay, so the mass is not the same, the volume is. So hopefully that helps you understand that question. Have a good day.